In this video, we are going to see how to build the enhanced IT ticket support intelligence bot. So it works with Agentic AI, and we have used CrewAI to create the agents, and it will query the database. In this case, it's an SQLite database which has all the ticket data inside it, and we can ask questions like, uh, give me a particular status and details of a particular ticket number, or all the open tickets, high severity tickets, and stuff like this. So you can see how it works and the purpose behind this in the previous video. I'll put the link of that video in the description below. So let's dive into the code and see how this works. Right, so I have the CrewAI agentic framework that I'm going to use here. In this case, you can ignore the open API key. You can use your own open API key or any other Gemini models as well. So the first thing we need to do is we need to import all the stuff. So agent, crew, process, task, LLM are some import statements, are functions that CrewAI gives us. So in CrewAI we can create different crews which allow you to have agents and tasks within that crew, and the crew performs a particular task. In this case, the entire crew does the task of finding the correct details about a ticket, but then you can have another crew which does all the other stuff like that, right? So that's the main idea behind this. So this is a very simple implementation, but does the work for a particular use case. Okay, so this is the documentation. I'll put this link in the chat in the description below again, and you can check. It has a lot of things here. There's something called as flow also. When you have multiple crews, then we need to make sure that there's a system where you can manage all the crews in a way that can give you accurate results. So that's where the flows come into picture, right? So in this video we'll just look at how crews were implemented for that particular use case. All right, so I have the GPT 3.5 turbo set, and we are going to use the SQLite database, where I've created a database already here, and the data in that database is something like this, which is the ticket number, open, closed, description, how it was closed, the resolution, by whom it was closed, the type, status, severity, and all other things. So this is something that when you work in an organization you would find these are some of the these are some of the fields that are compulsory, mandatory over there present, right, along with other stuff also, and the complexity of this would be higher there, but this would give you an idea on how this works. So this has been stored into the database, which is an SQLite database, and we are going to query that based on the input given by the user. Okay, so this is what we have, right? So when I say ticket status, it will update over here, and when I search, I can check the logs. So if you see, the crew execution has started. Let me go through that so I can show you how it works. So the crew execution has started, and it has called an agent called a smart IT support agent, and it will process a user query. This was the user query given as input, and these are the task specification that we have put in the code as a prompt for the agent to execute. Okay, so it's very specific to what it does, right? When it does all those things, it says task has been completed and the crew has been completed. Okay, and it will give you the status. It will also tell you which tool it was able to use or understand to run based on the input query. Okay, so if you go back, so if you see ticket 1021, it is closed. It will give you statistics also, so we can manipulate this the way we want the output to be. Okay, so since this was a simple status and details check, it has nothing to do for this. But when you go for a high severity ticket query, then it will tell you, hey, you got these many tickets in this domain, so these are the steps that you need to take, need to take. So you could see this example in the previous video, so you can check that out. Okay, so these are the logs that we get. Now let's see how we can implement this. So we come here. The first thing that we have is a crew base, which is given by CrewAI. Okay, so it has a class of crew. In that we have an agent. We give the name. So there are some predefined uh, roles, role, goal, and backstory that we need to provide to that agent, so it can answer the query in a better way. So I've told it, so this agent is a smart IT support agent, and it can do specific rules, selections, stuff like that. Now this is very specific to what we do, but it gives us accurate answers, so it's actually really helpful, right? And then provide comprehensive, well formatted responses with clear bullet points or relevant ticket details and professional formatting. Backstories is something very important that you can put in terms of what the use case is. Okay, so if it's an IT support agent with deep knowledge of ticketing systems, but you can put like it as the agent. Let's say if the agent is a architect, you could say it has like 20 years of experience in the architect domain, and it can answer questions related to specific architectures, domains, or whatever, right? Whatever the use case you are going with. Okay, and we have to tell which LLM it should answer questions with. Then the access of tools. Let me take this off. I had made some changes, so let me take this off. Right. So these are different tools that it will go and access. So in CrewAI, the framework we can tell it that whenever a question is asked, you have access to these tools, and make sure that you use these tools to run whatever the input query is. Okay, then word was true, maximum iteration is 3. So after 3 iterations, if you don't find, just reply saying that, hey, I couldn't find the answer that you were asking for, right? Or just rephrase your answer. Okay, then we have the task. uh, it's an enhanced support task where it says process the user query. So this is what we saw in the logs before, the query that was given as input, and you have these steps that you need to perform. So parse the query. So the LLM is smart enough to understand that if you give it a format something like this, then if you put anything over here, it knows that the entire thing is a ticket, and then this is the ticket number, and based on the ticket number, just go and run that particular tool, and that will give you the information, just like we saw in the example. So ticket TKT1021, this was extracted, and then that particular tool was executed, which was ticket query tool, where it could fetch those details, right? And then we have different uh, tools as well, right? Second step is the most appropriate tool. That's what it did. Then format whatever response you got and handle. Now this is where it becomes really interesting, and your purpose of the application is where you can think about how to solve the user's query and what to show as the output. So in this case, I've showed that give me all the information that you get from the response, but also provide a comprehensive response that includes all these things. You can play around with this, whatever your use case is, and that would give you the best answer. So if it doesn't have an answer, then you can just tell it. If you don't have anything else, just say that this doesn't apply for this particular question, and you can play around with this expected output, the description of the task, and stuff like this. And you have to, so for every task you need to assign an agent. So for this task, the agent that is this one, right? So now we have one agent and we have one task that that agent is going to perform. And to execute all of this, we have a function crew with the decorator crew, and we say this particular crew has agents, smart agent, and the task it has is an unsupposed task. The process is sequential. So there's hierarchical process also and the sequential process also. It says memory true, right? So you can get this in from the documentation, and there are different uh, parameters also. So if you see, come here, you have manager agent also. So this manager agent can make decisions to make sure that the query is should be answered by a particular agent only, and it can redirect your query to that particular agent. So right, so you can create an hierarchical structure where the manager agent has many different subordinate or sub agents, and that they can perform specific actions. So for this question, it could be go to the database and fetch. That would be one agent. Then it would be go to some other data source, let's say maybe your Jira, ServiceNow, or stuff like that, or a web search or something like that, and that could be a different agent that can perform that action. So one question goes to the manager agent. Manager agent can talk to two different agents and give them the input, and they can come back with some results, and you can have an LLM that would summarize the result based on what the user queries and just give the output which with whatever it is required, right? So this is the implementation using CrewAI. It's a very simple implementation, but very effective. It's one agent, one task, inside one crew. That's it, right? You can scale this with multiple agents within one crew, with one task, multiple tasks, and stuff like that. So the implementation is also very simple within the function itself, but you can convert this into a YAML file, and then you can just import that YAML file and you can make changes over there. So there are different ways that you can find it in the documentation. But to get started with this gives a pretty good head start for you, and then you can build on this. Okay, now the interesting part that we need to see is how it is able to fetch this information. So we know we have a list of tools. Now these tools, the purpose of this tool is to actually go to the database or the source where that information is present, and either do a SQL query, create an SQL query, or if you have already implemented the SQL query, you can just run that query, which I've done in this particular tutorial. And then there could be an API call if you want, there could be a RAG search if you want. So all these tools you can combine and do it. Okay, so now let's head to understanding how the tools were implemented. So here, let's go here, right? So I have the database, the path which is here, and the first tool. So in CrewAI, if you use @tool, you need to import this. So any function will act as a tool which you can configure it into your agent, and that agent will be configured into your task. So the crew will start execution, it will look for an agent, that agent has a task, that task and agent have some tools assigned to it. In this case it is ticket, so the input is a ticket number. Now what we have done is we have told the agent that you need to parse the input, right? So we have told the task that parse the query to find ticket number, status, severity, stuff like that. So when we ask a question, if it is able to find a ticket number, it is smart enough to understand that this is the function, or this is the tool that I need to run against this particular query. That is why it was able to extract the details that we got here. It got the ticket, it ran that tool, and it was able to get that information. If no results, just reply with this. It works. So you can do some parsing required and then just return the ticket. So this is only one tool, right? But then I've created a lot of tools. So there's a status one where the status could be open. So if I say give me all the tickets in the last 3 months that are in status in progress, then it would understand that this is the keyword that I need to extract from the input, use this tool, and make this query, right? When you make this query, it will give the results and return all the tickets with those statuses. So that's how I've created this tool. Then I have severity like high, medium, low. Then we have tag. If was it a database issue, was it a backend issue? So if you come here, I have tags. API. So this ticket was related to an API reported by Noah. It was closed for some stuff and it was done, right? So this is another tool. So the only thing that you need to do is you need to make sure you add this @tool and create a function, and that function can do anything, whatever you want. It could be a RAG search, again it could be a database API call or anything. Okay, in this case, for this particular tutorial and the hackathon that I and me and my friend had worked on, so this particular approach worked and it was giving us pretty good responses. So we went ahead with this, right? In the end, I did make a advanced ticket search also. So we discussed and we thought this could be a good tool where if you give me all the tickets with status as closed, but the severity is high, and maybe the tag was backend. Now, when these three conditions come, then the input is parsed with three different keywords, and all of this could be given. Since all of them are optional, it would work, right? Yeah, it's this. Okay, that would work, and then I just query it, and I query on whatever is extracted. If it's one, if it's two, or whatever it is, it works. If it's a list of keywords, that also works, right? There's still room for improvement. This was like a like a 3-day 2-day hackathon which we did. So it was very quick, and we did with the best possible understanding which we thought, and that's how this particular project was done. So this is how CrewAI works. Agent one task, assign the task the agent which who the agent is for that particular task, and it is able to query all the tools based on the input. So the smarter LLM you use, the smarter it is to understand and parse the query. And once your project or everything else starts to get a lot of complexity, like there are like 15 agents, there are 2 3 tasks, then this book becomes really complex. And that's where you need a manager agent. You need multiple crews executing parallelly, maybe stuff like that. So that's how this would work. But this could be a good head start for your project, and this is a completely working project which you can build on. Okay, now this is just the back end. The front end was completely made with Gradio. So the UI that you see is completely made with Gradio. So I don't want to go into the details of how Gradio works, but that's a very easy way to build machine learning or LLM applications with Python itself. So Gradio with blocks, that would give you a block, and then you do column, row, column, accordion, whatever you want. Then again the row where you're taking the input, then button, clear button, stuff like that. And it's a very easy way to create an application with Python. So this is the project. That's how Crew is built. This is how Crew AI works. This is a very simple implementation. Go through the code. If you find if you find any issues, let me know in the comments below. But this is how you implement. I am coming up with a better project also with multiple agents too. That would be in the near future. And I might connect it with an MCP server also, so that gives you the holistic approach in understanding how the entire ecosystem would work with MCP servers, Agentic AI, LLMs together, and how it becomes easier to solve complex problems. Right. So this is what I wanted to show you, the quick working of the project and how you can build on top of this. So I think all the files are open source, but it's on Spaces, which is Hugging Face's own version control, just like GitHub. So you can find all the files here. So if you have your own JSON, I do have a createtable.python file which you can just run it, and it will create the tickets.database for you, and you can experiment with this. So this was I participated in one of the we participated in one of the hackathons called as Agents MCP hackathon, and this was one of the submissions that we made. So that's it for this video. That's what I wanted to show you. uh, I hope you learned something, and thank you.